Well, welcome to the Geometry 2.6 notes. We're going to look at something called proofs. Now, if you mention proofs, maybe to your family members or people who've had geometry in the past, you'll probably get some opinions about them. A lot of times people feel like, why? Why would we bother studying proofs? And they feel kind of artificial a little bit. You'll see that today. I don't want to lie to you about that. What the reason we study proofs is because it teaches us how to provide evidence. It teaches us how to provide evidence for some claim. And if you think about that, you'll probably come up with some reasons why that might be an important life skill for you to have. There might be times where you're in a relationship with somebody and you're trying to convince them of something, and you're trying to provide evidence to convince them that what you're saying is true. That's going to happen a lot in your relationships. That could happen in your careers, even if your careers are not math careers. This could happen. Lawyers do this all of the time. People who work in marketing, they're trying to convince people that they have enough evidence for a claim. If you end up working maybe in a research lab or for a pharmaceutical company to create like medicines and drugs, you're going to need this so that you can convince people you know what you're talking about. If you're a journalist or a writer or a reporter or a news anchor, you're going to need to know how to do this skill. So we're going to do this through the lens of shapes and geometry. But please don't think this is a geometry thing. This is just a life skill. We're going to use geometry to practice this skill. Now, we're going to use something called two-column proofs as like a structure for this. Two-column proofs are just a way for us to organize our information. And this is the part I think that feels pretty artificial to people. People kind of go, I don't really know why we have to do it this way. There's actually a lot of different ways to do proofs, but the way that we're going to do it in geometry is there's going to be some statement, and it's going to be some specific statement, maybe talking about angle A or segment EF. And then we're going to provide some reason, some evidence that would allow us to back up that claim, that statement that we're making. This reason would be written in a very general language, very general, non-specific language, such as talking about a definition is the most common way. We could also talk about something called a theorem, which we'll kind of mention more as we go through these. So what a proof is, it's a series of statements that we make, and we use these reasons that provide evidence to back up our statement. Now, one of the reasons that we're going to use just a little bit later in this lesson is called substitution. You've actually used substitution before. You just may or may not remember having used it. But let me give you an example, a geometry example of how you've used substitution. Maybe you had a situation where you had two angles that are vertical, and maybe we have an expression for each one of them. Well, one of the things that we've learned in the past is that when angles are vertical, we can know that they are congruent. They have the same measure. So I could set them equal. Now I'm going to skip some algebra steps here. And we could find out what x is. Turns out x is 13 in the one that I made up. But let's say that the question didn't ask for x. Maybe we want to find out what's the measure of angle 1. Well, angle 1 has an expression. You guys have already this year been figuring out that if you want to find angle 1, what you could do is you could go to x and you could replace x with a value. And it finds out, then you could find out the measure of angle 1 that way. Well, when you're taking something and you plug it in, this is when you're using substitution, which is the property that we're talking about today. So if a and x are the same thing, maybe x is a variable, maybe a is a number, for example. That's the most common way you've seen it in the past. Then what we can do is we can take x and we can replace it with a. It can be replaced with a. Sometimes people call it plug it in. All right, plug it in, right in there. That's fine. I usually say substitute because that's really the math term. Now here's a list of a whole bunch of reasons that we might use in your proof, because what's going to happen is we're going to provide for you the statements. All these statements we're going to give you. Over here on this side, we're going to give you those, at least right now. Later on, maybe not. Your job is going to be to provide the reasons on the right-hand column. Now, common reasons, the first one is given. You'll see how that's used in just a minute. And then these other ones, we just talked about substitution. These other ones have keywords, and the keywords are going to be important because they're going to really help you know when you should use which one. So keywords, congruent is a keyword. Here's another congruent. Midpoint. Here's another keyword, congruent. Right angle, 90 degrees. You might see complementary, sum of 90. There's all these like little key phrases that are going to be important to help us know which of these we should use. You're going to not use all of them in a proof. You're going to pick one of them, maybe two of them, depending on how long the proof is. So here's an example of a proof. So in a proof, you're going to have some information that's given to you and then a conclusion. Let's just start with this one. This one says if angle A is 90 degrees, then we could make the claim that angle A is a right angle. Hopefully that resonates with you and you're like, yeah, that's what right angle means. Okay, so now how do we put that in a proof? By the way, sometimes there's a picture and sometimes there's not. When we're doing a proof, we're doing these 2-column proofs. Right now, we're giving you these statements over here. Your job is to fill out any missing reasons. Now, notice that the first statement is going to be the given statement, and that reason is given. In fact, if this is ever empty, we're always going to start with the reason of given. Okay, because that's what we're starting with. This is the information we're starting with. We're going to end with this conclusion that angle A is a right angle. That's where we're ending up. And our job is to find out, why can we say that? Why do we know that if an angle is 90 degrees, it's a right angle? Well, the reason we know that is because we know what the term right angle means. Let's take a look at our possible reasons. Kind of the key things that I'm finding here that I want to look for. I want to look for the key phrases of 90 degrees and right angle. Those are the things I want to look for. Now, looking through this list, 90 degrees shows up a couple times. But I also want to look for the phrase right angle. So this is the one I'm looking for because it has the phrase right angle and it has 90 degrees. This one I'm not going to use. It doesn't have the phrase right angle, even though it has the 90 degrees. So this is the statement I'm going to use for my conclusion here, for my last reason. However, it needs to be in the right order. Here's what I mean by this. We're starting with 90 degrees. We're ending with the phrase right angle. If you look at my statement here, you might notice that's actually written backwards. This is backwards from the proof. That happens a lot. Sometimes you have to take a statement and you have to just kind of flip it around and write it backwards. That actually has a term. It's called a converse. You don't actually need to know that term. But we are allowed with the definition to write it backwards. I want to start with 90 degrees. In my start, I need to mention 90 degrees. And with the end needs to match the end of my proof, which is right angle. So I'm going to take this statement and I'm going to write it backwards. Instead of starting with right angle, I'm going to start with 90 degrees. Now, both of these we're talking about, didn't mean to do that. Both of these we're talking about a right angle. We're talking about an angle. So I'm going to start with the word if. I'm going to end with the word then, but I want to start with 90 degrees. So I'm actually going to flip this backwards. My old conclusion is now my hypothesis. If it has a measure of 90 degrees, it's kind of awkward. I'll say, what is the if referencing? It's the angle. If an angle measures 90 degrees, you can kind of rephrase that a bit. And we can abbreviate. Look how I abbreviated 90 degrees. Then I want to end with the term right angle. I'm writing this backwards. Then it is a right angle. You might notice I'm using a symbol for angle. I'm also abbreviating a little bit. Right, I abbreviated. You can do that as well. All right, let's take a look at the next one. Here's another proof. So the given is going to provide step 1 for the statement, and the reason is always going to be given. That will never, ever change. And then our conclusion is going to be that y is the midpoint. Well, let's first look at the proof and make sure we agree with it. This says xy is congruent to yz. All right, so we're going to start off knowing that those are the same. Does that mean that y is in the midpoint? Yeah, because we know what a midpoint does. It takes that segment and makes it so it's equal on both sides. It's in the middle. So this seems to make sense. Now I have to find the correct phrase to go in here. So my key words or symbols, I see congruent and I see midpoint. This is what I'm going to look for in my list, congruent and midpoint. Let me go back to my list here. I'm actually going to take a quick snip of this list so that I can not have to toggle back and forth quite so much. So bear with me here. These are my options to work from. Okay, let me just put them somewhere that's a little bit more convenient, maybe over here. Okay. So I'm looking for congruent and midpoint. So I'm going to sort through my list here and look for congruent and midpoint. Now congruent shows up a fair amount, but notice I don't have midpoint. So these actually aren't the ones because I need it to talk about both congruent and midpoint. Here's midpoint. Here's congruent. This is the statement I'm going to be using. It might be in the correct order. It might not be. Now, this statement is still going to be written in a very general way. I'm not going to be talking about X and Y and Z. I'm going to just take this exact statement and I might have to change the order. I'm supposed to start with the word congruent. I'm supposed to end with the word midpoint. So this is written backwards, so I'm just going to rewrite it. The if part, these have to be written in if-then form. The if part talks about dividing a segment into two congruent statements when I flip this around and write it backwards. What is this, it? That's referencing the subject of point. So if a point divides a segment, I maybe didn't give myself enough room, into two congruent segments, then it is a midpoint. I chose the right statement that has the correct keywords. I want to start with congruent in the if part and end with the word midpoint in my conclusion. So I did it. Here's the next one. Now, they don't always have a picture. This one doesn't have a picture, but I've got angles E and F, wherever they are. They add up to equal 180, and the conclusion is that they're supplementary. Well, if I look at my proof, my given statement should be step 1, given, and this will always be true. Step 2, I need this to be my ending statement. I want to end with supplementary. My keywords in this proof, the keywords I'm looking for in this proof, I'm talking about things adding up to equal 180, and I'm using the term supplementary. 180 and supplementary. Now, another way to say things adding up to 180 is to use the term sum. They have a sum of 180. So this is what I'm going to look for in my reasons. Let me get rid of my old work. I'm looking for sum of 180, and I'm looking for the term supplementary. There's a couple 180s, but only this one has the term supplementary. This one has the wrong term. So this is what I'm using. If two angles are supplementary, then they have a sum of 180. Now I'm supposed to start with 180. And I'm supposed to end with supplementary. So I'm going to need to write this backwards. It's called a converse. So that I can have this match up. So here we go. I want to start with what used to be the conclusion. I'm going to start with if they, what is they? They is the two angles. Now these have to be in if-then form. If two angles have a sum of 180, then they are supplementary. So I had to write it backwards as a converse. When you write it backwards, it's called a converse. But I still start with the word if. I still have the form if then. I just change what was in the position for hypothesis and conclusion. All right, let's take a look at example 4. Oops, I got some extra stuff here I want to get rid of. Sorry. All right, example 4. Oh, more angles this time. Angle E is complementary to F, and E is equal to B. Okay, weird, a little bit different. Here's that original given statement. Notice the reason for that is always given. And then it says B is complementary to F. Okay, so this one might feel a little bit different. Now, the key word that I'm seeing is complementary. That's kind of my only key word. We've also got this equals here, which we'll come back to. If I look on my list for my reasons, there are some things that talk about complementary right here. But it has another keyword of 90, a sum of 90. You might notice that is never mentioned in here. I'm not using this. In order to use that, I'd have to talk about complementary and adding up to 90. I can't use that. So we must be needing something a little bit different than that. So let's take another look at this. If I compare the starting statement and the ending statement, they are almost the same. The only thing that's different is this. That's the only thing that's different. E has been replaced with B. And since E and B are the same, what happened here is they took this and replaced it. They plugged it in. Do you remember what that's called? That is called substitution. If you take a statement that you already have and you just take a part of it and you replace it with something that it's equal to, and once you replace it, this is the new statement, that's substitution. That one's a little bit different. All right, let's try example 5. Example 5, we want to write in the reason for the second step. Angle 5 and 7 are vertical. Okay, so that's written as step 1, given. It will always say given as the first reason. Okay, we don't have to write that, but that's always true. All right, and now it says that they are congruent. That will go right here. Okay, so trying to figure this out a little bit, the key words that I'm seeing are vertical and congruent. So I'm going to look at my set of reasons and look for vertical and congruent. Let me move these down. Vertical and congruent. Okay. So I do see that actually. See if you can find it. Vertical and congruent. That's this one right here. Now I might be able to use it in this order. I might have to write it backwards. The way you know is the order of the proof. Where did it start? It started with vertical. That's actually where this definition starts, or this is actually a theorem. And where did it end? It ended with congruent. That's what we write here. And since the order matches, we get to keep it the same. If two angles are vertical, then they are congruent. Sometimes I take out words like they and are. It's up to you, but make sure we're using the right one. All right, this one. Looks like we got a little diagram that moved kind of funny, so let me see if I can fix that here. That's angle 1. This is line Q and line P. Sorry about that. Okay, given that P is perpendicular to Q and angle 1 is a right angle. Okay, and if you'd forgotten, this symbol right here is perpendicular. Is perpendicular. So notice the way this is written, my first statement is from the given. My last statement is from the proof. I just have to provide the reason. My key phrases are perpendicular and right angle. In that order, perpendicular and right angle. So, singular, sorry, not plural. So let's take a look at my options here. I'm looking for perpendicular and right angle. I have that right here. If two lines are perpendicular, then they intersect at right angles. Now we wanted to start with perpendicular and end with the right angles. So this is correct. This is the correct one that we're going to use. We're just going to put that in for this last statement. If, you have to write the if and the then, two lines are perpendicular, and you can write the symbol, then they intersect at right angles. Now I know you might notice this says angles plural, and this is only talking about one right angle, but it is still the same keywords. There are actually 4 right angles here. We just are only talking about one of them in our problem. Okay, so if you look at the last two examples, you might notice that we have 3 steps this time. 3 steps this time. So this is a little bit different this time, and we're going to have to figure out how. These are, of course, the harder ones. This is a little bit more advanced. So the given will match all of the given statements, even if there's more than one. The prove, the very last one, will be the very last statement. And we've got this intermediate one. Okay, well, let's just look at the picture first. Looking at the picture, it says angle 2 is congruent to angle 3. I'm going to actually mark that on my picture. Those are congruent. And it says 1 and 2 are vertical. Yeah, we can see that from the picture. We can see they're vertical. All right, well, let's look at the reasoning. This says angles 1 and 2 are congruent. Is that true? Look at your picture. Is that true? Hopefully you can say yes because of where they are positioned. The reason that these are congruent is because they are vertical angles. Now, I'm going to pull this right here as my start of this. For this one, I want to start with vertical. For step 2, I want to start with vertical because these are vertical angles, and I want to end with congruent. The reason I want to end with congruent is that's why I'm ending to get the statement in step 2. So I want to look at my options here, and I want to start with angles that are vertical, and I want to end with those angles being congruent. Well, I do have that. I have that right here. And so what's happening here is I know that they're vertical. That's my if. If 2 angles are vertical, and I know then that what I need to be able to say is that they're congruent. That's my support, my evidence for step 2. And I have a reason that matches that. Okay, so now on my diagram, it might be helpful for me to mark them congruent. And then take a look at step 3. Step 3, you might be like, I don't know. But what we want to recognize is that step 3 sure looks a heck of a lot like step 2. The only thing that's different is that 2 and 3 have been replaced with each other. Instead of angle 2, I'm now using angle 3. Well, in my given, remember 2 and 3 are the same. So I'm allowed to take this angle 3 and plug it in to step 2 and replace it. And so when I replace something, that is called substitution. You might want to put a star next to this proof. You might need to reference it again. All right, our last one. We are told that AB is congruent to CD and AB is 8 centimeters. Please notice my step 1 is the given statement with given as the reason. This one, the final conclusion is going to be right here. The final conclusion is going to be right here. Step 2, not everybody would do step 2 if they were creating this proof from scratch, but we just want to just show you one way of thinking. One way of thinking, and this is kind of unique, right here. And this actually is something that is a little bit obscure for students. So you might need to put a star next to this one, is that these two statements are almost the same. If we are starting with things that are congruent and we end with the exact same statement, but it got changed from congruent to equals, what we're using here is what the definition of congruent means. Let me kind of show you on all of our options here. There are these first 2 statements, or first couple ones here that we're going to look at. If 2 angles are congruent, then they have the same measure. If 2 segments are congruent, then they have the same measure. These are really identical except for one's talking about angles and one's talking about segments. Now, we're not talking about angles in this picture, I don't believe. That's right, we're talking about segments. We're using this. What the whole same measure means is same measure means that they're equal to each other. If they're congruent, then they are equal, is essentially like how we could phrase this less formally. So I'm going to be using this as my statement. If 2 segments are congruent, then they are equal. And so if you ever want to change from congruent to equal, you could use this as the reason. Oh, sorry. Then they, I apologize, have the same measure. Same measure is kind of how we want to interpret equals. All right, the very last part of this, you might notice, okay, we did talk about 8 centimeters one other time right here. If I compare that statement and my ending statement, they're almost the same. The only difference is AB has been changed to CD. In step 2, AB and CD are the same thing, so I'm allowed to take AB and replace CD. This is substitution. If you see a statement and my goodness, it's almost identical, but one thing has changed, it's probably substitution. That is the end of our notes for today.